Right now, something from another star system is threading its way through our cosmic neighborhood, and its arrival has set off alarm bells among astronomers and conspiracy theorists alike. On October 1st, 2025, 2 days before the third known interstellar object would make its closest pass, NASA's public communications went dark. Over 15,000 personnel were furloughed. Websites froze. Data feeds were severed. While the skies prepared for one of the most astonishing celestial events in decades, the government calls it a budget impasse. Scientists call it catastrophic timing. Some are asking a different question entirely. Is this merely a coincidence? The visitor in question is called the third confirmed interstellar object ever discovered. Unlike the more familiar comets or asteroids, this object is moving through our solar system on a hyperbolic trajectory, daring to defy our gravitational hold. What makes 3I/ATLAS especially compelling is its scale and behavior. Estimates of its core diameter range from a few hundred meters up to 5.6 kilometers, though even the upper end is cloaked by a hazy, glowing coma of gas and dust, making the solid nucleus invisible in most imagery. Spectroscopy from the James Webb Space Telescope reveals a coma that is unusually rich in carbon dioxide, CO2, perhaps the highest CO2/H2O ratio yet seen in any comet. When first observed via the Atlas survey in Chile in July 2025, the object's trajectory already hinted at interstellar origin, not bound to our sun. Over time, telescopes and observatories around the globe built up a data set of its motion, brightness, spectral lines, and activity across a span of months. As 3I/ATLAS prepared for its closest approach to Mars on October 3rd, the timing could scarcely have been more perfect. Mars orbiters and the Perseverance rover were ideally positioned to image and spectrally analyze the object from a vantage point no Earth-based telescope could match. But on October 1st, NASA's real-time public access was cut off. Websites went dark, press updates ceased, and data feeds were shuttered, all as the interstellar visitor was about to make its most revealing flyby. The blackout sparked intense frustration across the scientific community. Astronomers who had prepared weeks or months in advance found themselves blocked from sharing results. Some voiced that, if ever there were a moment to keep the public informed, this was it. The overlap of NASA's communication freeze and this cosmic rendezvous feels far more than mere unfortunate coincidence. Meanwhile, a faint glimmer broke through the silence. On October 2nd, just 1 day before Mars' closest approach, the Perseverance rover recorded a curious streak in one of its long exposure sky images. It didn't align with Martian star trails or expected satellite paths. Spanning several consecutive frames, the line cut diagonally through the field in a consistent trajectory, too systematic to be noise or a cosmic ray glitch. A Twitter user named Drew flagged the anomaly, sparking scrutiny among researchers. The timing, speed, and direction all lined up with what would be expected of 3I/ATLAS if it were viewed from the Martian vantage point. In short, the streak was almost certainly the object itself, captured in an alien sky. This may be one of the first true views of an interstellar object from another planet. It's a fascinating twist. While Earth is blind, Mars's robotic observers may have caught a fleeting motion across their lens. True comets tend to behave in predictable ways. As they approach the sun, frozen ices vaporize, expelling gas and dust in jets. These jets push the nucleus slightly, causing small non-gravitational accelerations that can be measured. But 3I/ATLAS doesn't quite play by the rules. Based on observed outgassing, scientists expected a measurable push. Yet the deviation from a pure gravitational path is unexpectedly weak, under approximately 15 meters per day squared. A dense, massive core would resist perturbation more than a fluffy comet, meaning the object may be far heavier than initially presumed. Some studies estimate its mass at over 33 billion tons. That's 3 to 5 orders of magnitude more massive than prior interstellar objects like Oumuamua or Borisov. The math is jarring. The odds seem stacked against discovering such a heavyweight wandering through space first. Then there's the curious resilience. On September 25th, a coronal mass ejection, CME, from the Sun struck 3I/ATLAS, a powerful solar storm capable of stripping gas and triggering fragmentation. Yet subsequent observations on September 27th and October 2nd revealed no catastrophic breakups or sudden structural changes, only gradual expansion of its coma. It as if the comet barely registered the impact. That level of structural integrity is highly unusual. All of this has reignited the boldest hypothesis. What if 3I/ATLAS is not entirely natural? Harvard astrophysicist Avi Loeb, known for his provocative views, has pointed to several red flags. The high density, the weak non-gravitational acceleration, and some reported detections of nickel without iron are puzzling. Nickel-rich alloys are rarer in natural bodies but common in engineered materials. Loeb developed a scale, the Loeb scale, to gauge the likelihood of alien origin and has tentatively given 3I/ATLAS a rating of 4 out of 10. Not conclusive, but provocative enough to demand further scrutiny. He remains cautious. In public remarks, he assesses that natural origins are still 99% likely, but he emphasizes that scientific curiosity demands we explore even the 1% possibility. Critics, many of them prominent astronomers, push back hard. They argue that calling an object alien when natural explanations still fit stirs sensationalism. History, they note, shows that extraordinary claims demand extraordinary proof. And compared to prior cases, Loeb's thesis bears strong resemblance to his earlier speculation about Oumuamua, which itself was met with intense skepticism. Still, Loeb's larger point is philosophically relevant. If we limit artificial to what we already know, we might miss signs of technology designed under alien logic. The cosmos might harbor objects that mimic nature so closely they evade detection by our biases. Stepping away from aliens, but still in radical territory, some scientists propose a different impactful role for interstellar objects: planet seeding. This idea, championed by researchers like Suzanne Finer or Falzner in recent models, suggests that massive interstellar visitors could act as preformed cores injected into young protoplanetary disks. Planet formation theory faces a timing problem. Gas-rich disks around young stars dissipate within a few million years, sometimes too fast for cores to grow large enough to attract hydrogen and helium atmospheres. But if a foreign body bearing mass and gravitational pull arrives already several kilometers across, it could jumpstart planet formation. Simulations show that more massive stars are more efficient at capturing such objects, which dovetails with observations that gas giants tend to orbit larger stars. In this view, 3I/ATLAS is not just a visitor, it's a cosmic seed. Some speculate that such seeds may have played a role in planet formation in distant star systems, and perhaps even in ours, billions of years ago. With Earth-based observatories effectively blinded by sunlight, the burden of observation now rests with spacecraft. ESA's Mars Express, the ExoMars Trace Gas Orbiter, and NASA's Perseverance rover are our immediate hope to gather images and spectra from Mars's vantage. Meanwhile, The JUICE mission, en route to Jupiter, may intercept 3I/ATLAS as it moves inward toward perihelion, currently expected around October 29. However, signal interference from solar radiation will slow down data return. Even when JUICE or other probes collect high-value information, Earth teams may not see it until days or weeks later. That delay builds tension. Somewhere, locked in instrument memory, may lie the key to understanding whether 3I/ATLAS is a comet, a technological artifact, or something entirely unexpected. When the data finally arrives, scientists will put it all together: spectra, images, trajectory, polarization data, gas ratios, coma behavior, to see whether nature or design fits better. 3I/ATLAS is more than just a curiosity. It's a mirror reflecting our limits, our biases, and our ambitions. It challenges us to stretch our definitions of natural and artificial. It may reshape how we think about the frequency of interstellar travelers. It may hint at unknown mechanisms in planet formation. And it forces us to confront what transparency in science truly means, especially when secrets feel too well timed. In a few months, 3I/ATLAS will slip away into the darkness again, vanishing beyond the reach of even our most powerful telescopes. The window to study it is razor thin. Did we make the most of it, or let it drift away behind fences of bureaucracy? Some will say the shutdown was an unfortunate coincidence. Others will see a calculated silencer at work. But ultimately, the data doesn't lie. When all the pieces are assembled, we may finally see what 3I/ATLAS really is, or isn't. Until then, we wait, we speculate, we peer at the void,